Hi, welcome back to another episode of Algebra and Words, the video series on YouTube. We're going to continue our conversation tonight about systems of two linear equations. Alright, I gave an overview of them in a previous video, and I told you that there's basically four methods that you can use to solve a system of two linear equations. We're going to do three methods in these video series, and I might do the fourth method, which is solving by matrices, in a video much later. So let's get started. And the method that we're going to look at tonight is the graph and check method. If you want to follow along with this in written form, you can follow along with it in my book Algebra and Words, and I go over the graph and check method starting on page 59 in the book. The link for that on Amazon is in the description box below. So anyway, let's get started. Now, one of the methods to solve a system of two linear equations is what I call the graph and check method. Some books might call it the check method, some books might call it the graph method. I kind of have them hybridized as one because really you have to basically do both. It really all depends on what the book or the question gives you. There's kind of three types of forms of question that you could be given. And it all just involves a little bit different amount of work. One type of form is kind of a more simple one, and I think they do this to sort of build you up to the harder type. The easiest type is they give you two equations, they give you a test point, and you have to basically find out by testing if this point is the solution to this system of equations. Okay? And so how would you do that? Well, we'll do that in a second. But basically, what I'm trying to say is one way that they could give you the question is they could just give you the point and you have to test it. Okay. A second way is they give you a graph and also the equations. I didn't write the equations yet because I'll pause that and put that up in a couple minutes once we solve that. But again, a second way is they give you the graph and you're supposed to look at the graph and sort of visually make an educated guess at the test point. They also give you the equations, which I didn't write here, but I will put up. Then you take the point, just like here, and do the method I'm going to show you to test. The difference between this way and this way is in this one, they give you the point, but in this one, they give you the graph, and you have to find the point yourself on the graph. It's basically the same thing, but you could get either type of question. A third type of question is they don't give you either. They don't give you the point, and they don't give you the graph. They only give you the system of the two equations. And it's then up to you to construct everything. Okay, I'll go over that in a couple minutes, but to give an overview, well, we'll go over it in a couple minutes. Let's focus on this problem first. So I'll leave this up because we don't need that much room, but this is the method that we're going to use to test a test point to see if it's a solution. Okay? Before we do the math, this is what you need to do and how you're going to analyze the final outcome. You're going to, one equation at a time, you're going to take the x value and the y value and substitute them into the equation, one equation at a time. And all you're going to do is simplify down as much as you can. Once you do that, if the left side equals the right side for both equations, it has to be both, then that tells you that the point that you tested is the solution to the system of the two linear equations. If either of those two equations do not come out where the left side equals the right side, then that means that the point you're testing is not the solution. And that's pretty much the end of the problem. Alright? So let's get started with this. All we're going to do is, starting with this equation, we're going to just plug in the values. So I'm going to do that below, and so we're going to put 2, and in for x is -4, and in for y is 1, and that equals -7. I had to put the negative sign in there. This 2 times -4 is -8. Again, plus 1 equals -7. -8 plus 1 is -7. -7 equals -7, right? So usually I just put a check mark next to that to show that it checks out. The left side equals the right side. Okay, and now let's do this equation. Let's just squeeze this up here. Again, write the 3, and for x we're going to put -4, and plus y again, which is 1, and this one equals -11. So let's simplify as much as we can. On the left, 3 times -4 is -12, plus 1. -12 plus 1 is -11. And now notice that the left side equals the right side. -11 equals -11. I'd like to put a check mark next to each. The left side equals the right side for both equations when we substituted the values of the test point into each equation. And what does that mean? That means that that point is the solution to that system of two linear equations. Alright, so I'm going to erase that. Then we're going to look at the next problem, of which I have the graph already on the board. Okay, I put another problem on the board. I put the rest of the problem up. We already have the graph. We're given the graph, and we're given the two equations. The first step here is to look at the graph, and with your eye, use your best judgment to try to determine where the lines go through the graph. Okay, and I can tell you, the books and the questions you're given will likely be set up so that it goes cleanly through one perfect point, which are made of whole numbers. In other words, not fractions or decimal points. It should be an obvious point. So if I look at this, and if I look right around here, that tells me that my educated guess for the point they cross is -1, -2. So this is now my test point. We're now going to do the same process that we did a minute ago in the last problem to test the point to see if it works out. So remember, the procedure is we're going to take -1 and -2, put them in for their respective variables in the original equations, one equation at a time, simplify them down, and then we're going to see if the left side equals the right side for both equations. So let's get started. Let's do this equation first, and we're going to do -3 times -1 in for x plus -2 in for y equals 1. Let's simplify. -3 times -1 is +3, and plus -2 is going to be like -2. Bring down the 1. 3 minus 2 equals 1. So 1 equals 1. I put a check mark next to that because they do check out. The left side equals the right side. But we still need to check if that happens for the other equation as well before we make our final decision. Okay, so let me squeeze that in here. We're going to put 4, and in for x, -1, -2, and in for y, -2. And that equals, I have to squeeze that in there, 0. 4 times -1 is -4. And -2 times -2 is +4. And -4 plus 4 equals 0. So we get 0 equals 0. That checks out because the left side equals the right side. And since the left side equals the right side for both, when we substituted the test point in, that tells us that this point and the point that we thought was the point is the solution. So circle that, and that tells us that that is the solution. One quick thing I want to point out before we end this video. Notice that we have number equals a number or 0 equals 0, okay? In the previous video where we talked about the 3 categories of systems, in other words, either an independent system, consistent, inconsistent, or dependent. And if you remember, for dependent system, I told you that one indicator might be when the left side equals the right side, or a number equals a number. That's not when you're doing this method. This method is taking the test point numbers and